Good morning, everyone. Today, I'm excited to present our recent work titled Enhancing Online Video Recommendation via Coarse-to-fine Dynamic Uplift Modeling Framework, which was accepted at RecSys 2025. This work is a collaboration between researchers from KuaiShou and several academic institutions. I'll walk you through the motivation, methodology, and the results of our study. Let's begin with the background of the problem. Here is our category. Short video platforms like TikTok and KuaiShou have seen explosive growth in recent years. However, traditional recommender system mainly focus on ranking individual items without explicitly managing the distribution of content types. For example, balancing short video versus long videos. This leads to two main challenges. First, users' preferences shift rapidly, and one size fits all strategy doesn't work. Second, we need a personalized way to decide which type of content to show each user. To address this, we introduced uplift modeling, a technique widely used in marketing to estimate the individual level treatment effect of showing different types of videos. Based on this idea, we proposed the CDUM framework, which combines long-term user preference and real-time interest to make dynamic distribution decisions. CDUM stands for coarse-to-fine dynamic uplift modeling, and it has two key components. First, the coarse-grained preference modeling module. This is trained offline to capture users' long-term preferences and estimate causal effects of different video types using multi-treatment uplift modeling. Second, the fine-grained interest capture module. This runs online and captures real-time user intent based on current context and candidate videos. Together, these two models compute an uplift score for each treatment. If the score exceeds the threshold, we apply the treatment. For example, increasing the proportion of short videos for a specific user. This framework allows us to make a personalized and dynamic content distribution decision in real time. We evaluate our method on both public and industrial datasets. For public datasets, we use Lazada and Criteo, which are widely used in uplift modeling research. For industrial evaluation, we use random controlled trial dataset from KuaiShou. We compared our CPM model with several strong baselines, including S-learner, T-learner, EFIN, and DESCN. We use standard uplift evaluation metrics such as AUUC Gini lift at 30. As shown in the table, our method consistently outperforms all baselines across datasets, demonstrating strong generalization and stability. We deployed the CDUM in the cascading rank stage of KuaiShou's real-time recommendation pipeline. Here, the system decides whether to apply a certain treatment, such as increasing short video exposure based on predicted uplift score for each user request. We ran a large-scale A/B test for 18 days, covering hundreds of millions of users. The results are impressive. Daily retention increased by positive 0.034%. App usage time increased by positive 0.135%, and LT7 improved by positive 0.048%. This shows that CDM is not only effective but also efficient enough for real-time deployment. To summarize, we introduced a novel uplift modeling framework for video recommendation, which goes beyond the traditional ranking. Our CDUM framework combines long-term and real-time user modeling to make dynamic distribution decisions. It significantly improves user engagement and retention in both offline experiments and online deployment at KuaiShou. The code is available on GitHub for the research community. Thank you for your attention. I'm happy to take your question now.
So how did you measure the long-term effect of your approach? Because I saw you measured the retention, right?
Yeah.
But have you considered other measures like user engagement and the satisfaction?
Our main consideration about the retention is the app usage time. Yeah, that's a crucial metric of to reflect the retention behavior of people of users.
But the retention may not reflect whether users are really satisfied with the short video or not.
Yeah. Besides, we have evaluated this our methods online, and we conduct A/B test for more than 18 days.
Okay.
And the online metrics shows that the users are satisfied with our methods.
Through retention, right? This metric.
Yeah.
Okay.
Yes.
Okay, thank you. There's one question. So how sensitive is CDUM to the uplift score threshold? And do you adapt it per user group?
Sensitive. Yeah, we have conducted this method to some cold start users, and the metrics we don't show it on the paper, but we will supply it in the archive version.
Okay.
Yeah, it shows. It also shows significant improvement.
Yes, please.
So when you do the uplift modeling, did you need to design experiment to collect training data, or you just use your your data from the past user behavior, because there are counterfactual effect in the data?
We just conduct RCT experiments online to collect the training data.